Democratic Socialists, a vocal minority, and a, quote, small group of activists that manipulate the facts to perpetuate their own agendas, unquote. The APCC said in a statement that the emails show General Foe's political bias. No comment from the Guard. Tim Dunn, WBZ, Boston's News Radio.
538, we check the business world now, brought to you by Brookline Bank. It's bank.
So you're surprised, so am I. Hey, you have to give a lot of credit to that miracle that we call feedback. So big surprise, it worked. I mean, I didn't think it would work. As applied to the KORG NuTube. We'll go through the whole process in this video and see how we were able to make the NuTube work as a Regen receiver. I still don't have the audio straightened out. I don't have the transformer in here. I just used a 300K resistor and cap coupled off into our original LM386 amplifier. But I think you're going to enjoy this video. And the KORG NuTube works at RF. Who knew? So winding the coils for the NuTube is going to be challenging. And working with plug-in coils is tough enough. But having to fool around with the tickler coil, changing turns, increasing, decreasing, whatever, I decided to come up with an idea where I could wind the main coil on a regular coil form, and then I could put the tickler coil on this tickler girdle that goes around the main coil, and that will have the tickler wires coming out and wiring directly to the socket. This is going to allow me to optimize the tickler without having to completely rewind the plug-in coil every time. Also, I had some comments about the two coils that I had wound for the broadcast band, one covering the low part of the band and one covering the upper part of the band. Most projects will tell you just have one plug-in coil for the broadcast band. But really, to cover it fully, especially with fine wire like this number 28, you have so much capacitance on the turns that you really are limiting your swing with a simple 365 picofarad capacitor. So it's much easier just to wind two coils. One that will guarantee you can hit the low frequency, and this is usually about 125 turns on the primary and 20 to 25 on the tickler, and one for the high end of the band that starts around 800 kilohertz and takes you up to 1750, and this is usually about 90 turns with about 20 turns on the tickler. So just wanted I wanted you to see those two broadcast band coils up close. So before I start to tear this Twinplex apart, I wanted to verify that my tickler coil system was going to be useful, and I've done an overwound tickler coil. It's got 60 turns on a slightly larger diameter, so I can guarantee that I'm at least 2 to 1 on the primary to tickler coil ratio. That should be so much feedback that we can tempt the KORG NuTube into oscillation. At least that's my thinking. Now, one thing we should try is, will it still work with an original tube? And will it work with 12AX7s, which would not oscillate reliably at all with the original feedback in the original coils we were working with? So that would be a good test. Okay, this is WBZ, and I'm verifying that it works with the, and so we're going into regeneration quite low. Let's try one of those troublesome tubes, the 12AX7. So with this 12AX7, it's really working quite well. It's going into regeneration. It's going into regeneration about halfway with the trimmer further up, which is a sign we have a lot of feedback. Let's turn the trimmer up full.
Good, Mike. Thank you so much.
So even with the trimmer totally maxed out, with the 12AX7, we can now regenerate at half. So this excess feedback is showing it's really going to force the tube to go in. So I think I'm satisfied that this is the right approach with the KORG. We'll start with excess feedback to try to get it to work. So while we happen to be here, just before I start to tear this thing apart and adapt it to the KORG NuTube, let's talk a little bit about the Twinplex. Okay, I think we really would like to go through the original Twinplex. As you can see, the Twinplex is a simple two-stage regenerative with one audio stage. We've got the classic grid leak bias on the input, the Armstrong tickler feedback, and the 470 puff, which is your RF bypass for the feedback. We know that as we lower the value of this capacitor, we can reduce the value of the feedback, so that's why the throttle capacitor is put in this position. In the Twinplex, however, we control the regeneration over here with this potentiometer. We're actually changing the voltage going to the regenerative stage, and that's another way of reducing the gain of the stage by lowering the voltage. The audio itself is developed across this 100K resistor, which takes the place of the typical choke that would be in this position. The audio goes down through the 0.01 mic capacitor. There's a volume control. It's the old-fashioned type that connects the grid straight to the volume control. So there could be some rubbing noise here because there is DC flowing. The DC that's set up by the bias network in the cathode of the audio amplifier tube. We've been running it on 60 volts DC instead of 90, and we tried it on 25 volts. So that's pretty much the rundown on the standard Twinplex. Coupling very simple right into the top of the tuned circuit, and we know this is another thing that influences the amount of feedback you get. So this is the 12BH7. It's going into oscillation almost immediately. Let's clamp down on the trimmer. Trimmer is now full. Again, we can get that to...
I'm trying to find the bat. It didn't come from a bat. It came from a mouse. A humanized mice. The humanized mice that were sent over from a lab here in the United States over to the Bat Lady.
The Bat Lady.
Actually, there was a...
So the message is, if you're just trying to build a Twinplex and you would like to operate the Twinplex on very low voltage, voltages between 12 and 24 volts, you might consider increasing the tickler coil from 20 to 25 turns to maybe 35 to 40 turns in order to get it to regenerate properly. So let's take a look at the modifications that we had to make to the Twinplex schematic to try to make the NuTube work okay. We have the directly heated filaments here. We don't have any cathodes, so it has to be grounded basically because you can't separate the tubes. In this circuit, I'm using 270 2-watt resistors. Using Ohm's law, we subtract the 6 volts from the target 0.7 volts and then divide by the desired current that we want in each leg, and we come up with around 270. I'm going to attempt to use grid leak bias on the first stage. Have no idea if this is going to work or not. Sort of a self-regulating, self-biasing circuit with the KORG NuTube. We shall find out how self-biasing it is. And I didn't really do much in the way of the topology of the tickler coil other than making it 2 or 3 times larger than normal. I'm leaving the 470 puff RF bypass and the 2.5 millihenry choke. I did worry a little bit about the audio amplifier. So I have a bias network that's basically 3 volts and a 100K pot, and this will eventually destroy the battery through leakage, but you know what, that's going to be some time down the pike before that actually kills that battery. And we know we need a couple of negative volts to properly bias the audio amplifier stage at the requisite 20 microamps. So we do not over dissipate the audio amplifier on the NuTube. This 10K resistor is simply to be able to measure that 20 microamps accurately using my digital voltmeter. Regeneration control is untouched. I think this is going to help because if the pot is down on this side, we're going to have 0 volts on the plate. We can slowly bring it up and hope that the stage goes into oscillation. I do not have the transformer that I wanted to use to drive the headphones. That will be coming. Instead, I put the requisite 330K resistor on the audio amplifier, and I'm using a coupling capacitor going out to our original LM386 amplifier. So that's the whole setup. And I am going to attempt to use 60 volts and see if we can't either make it work or blow up the KORG NuTube. It is time to look at some of the features that had to be incorporated in order to let the KORG NuTube take its place on the Regen deck. And right off the bat you can see I've got a couple of ugly resistors here. These are going to feed the filaments. The center taps are grounded with these 2 black wires, and the filaments are serviced with 270 ohm 2-watt resistors. They're actually a little higher than that because they're vintage. And I have a 180 and a 68 here. So these, I didn't have a couple of 270s, so I made a couple of 270s, and that's going to handle the filaments. Notice there's nothing hooked up, no power supply yet. Power supply is over that way. However, I want to get the bias set first. So you can see I've got 2 penlight cells here, and the bottom of the potentiometer right here, you would like to have that set so that we have the full, close to 3 volts, I guess, negative. That's going to bias the stage off. We don't want the stage to suddenly hog current when we put power on it. So basically I have this pot set up here so that I can adjust. I've got the negative on the I've got the negative on the positive lead. Let's take that off there for now. We'll put the negative on the negative. How's that sound? And let's see if we can read something on the potentiometer. Okay, I'm sorry. 1.9 volt negative. Can't see that. Let's get on there again. And we can turn it up as high as negative 2.8 and as low as 0 to negative 2.8. So we'll keep it at negative 2.8. That's definitely going to cut it off at 60 volts. We're going to start running this thing on 25 volts, however, just for safety's sake. Okay, so we now have the bias set, and people are saying, that's a strange circuit. You're going to discharge those batteries in no time with that bias circuit. Well, it's going to take a little while, let's put it that way. Well, let's just say it'll take a while for the batteries to die, but I'd rather have the safety bias there all the time. I don't want it on a switch. I don't want to forget about it. I want it to be there all the time. Okay, let's look at some other features. I mounted the NuTube with 4 standoffs, and over here on the side I have a standoff that goes to ground, so I put that onto the ground. It really doesn't do anything, but it's sitting there. The tickler coil is attached to plate 1 and the top of the choke. You can see where the plate 1 is going over to the tickler coil, and then the tickler coil goes over to the choke. What else can I show you? Oh, I added some shielding between this point here. That's just asking to pick up hum. So I have some shielding I added to that point. I might have to add more shielding. Now, the transformer has not come in yet. I ordered one. So I put a 390K resistor right here. The 10K, he's there so I can measure the current accurately. He's just there so I have some way to measure the current that I'm sending into the plate. I want to make sure I don't put in any more than 20 microamps. So with a 10K resistor there, 20 microamps will read 0.2 on my digital voltmeter. So I'm coming off that point with a 0.1 that's going to the output and a regular ground. A lot of people are going to like this hookup because it's there's no DC on the headphones. Well, we're not sending it into headphones for this first test. We don't have the proper transformer yet. So I'm going to send it into the LM386 just as it is, and we'll probably have to crank up the LM386 full blast. But that's okay. We'll be able to tell if we go into regeneration. So let's hook this up to 25 volts and 6 volts. Let's see if this thing burns up on first application of power, money down the drain, and so on. Let's see if we can at least get the filament lit without burning up the chip. So I forgot 2 very important capacitors. These 2 right here. These bypass the filament, and if these are not in there, you can get some beautiful noise in the cathode. Remember, this is a directly heated triode system, so you really need to keep this very, very clean and well grounded. So those 2 1 microfarad bypass caps have now been added. You can see them here and here. We're now going to apply the filament. Okay, I brought it up slowly on the variac, and what I saw was as soon as the 6 volt regulator came in, it pretty much came to voltage. So I was kind of stupid, thinking that the variac would do much. So let's see what we got on each one. Okay, this is with no B plus attached. 25 or 60, not attached. Let's look at each filament. 0.720, that's within range. 0.701. Excellent. So we're lighting the tube. Does the tube feel warm? No. Anyway, the tube is lit. The next thing we will try is to apply 25 volts to it and see what happens. Now, I have done nothing dramatic on the regen side. There's no bias there. There's no protective bias at all. So it should act like a grid leak type system, and we'll see what happens. I am taking precautions, however, on the amplifier side, where we have the full 60 volts. Remember, the regen control is supplying the B plus to the detector stage, so it's way low. Let's see what that voltage is. Okay, let's measure the volt. We have 25 volts. We're going to measure the voltage on the Regen pot. This is going to the plate of the first half of the tube. Okay, 5.4 volts. That should be safe. There's no bias. That's not going to upset anything. But on the amplifier side, where we have the full 25 volts, hopefully our protective bias is keeping the current fairly low, but we need to measure that. And that's what that 10K resistor was all about I put over here. Let's see if I can get across that. This is kind of going to be our way of measuring current. Okay. 8.9 millivolts. That's pretty low current. I just adjusted the bias on the audio amplifier, and my gosh, it's starting to fluoresce. I've got 10 microamps flowing. You know, that's 200 millivolts on the meter is 20 microamps. 100 millivolts on the meter is 10 microamps. So we're probably on the load line somewhere with that stage, and it's fluorescing. Now, I think it's time to hook up the LM386 and see if we can hear anything, hum at least. So what is the first thing you do when you're testing an amplifier and you want to see if the stage is working? The finger test, right? The hum test. So you take your finger and you put it on the hot. Okay, that's right on the grid of the tube. So I can say that stage is amplifying. I don't know how much, but it is amplifying. So next, let's see if we can get the RF to come up by putting some bias on the regenerative stage. Okay, we did our hum test. Now we're going to begin to bring up the regenerative potentiometer. So I'm going to reach over here to the Regen pot. Let's see if you can see what's going on here. Let's start to bring that up. Remember, this is just grid leak bias. There's no bias on this stage. Starting to fluoresce.
For more information, you can visit us on the web at compassion.com. I'm Dr. Wes Stafford on behalf of Compassion International, encouraging you to lighten up.
We're here for you 24/7. Life-changing radio. We are at AM 1320, 92.1 FM, radio.com, or on your smartphone or tablet when you download the life-changing radio.
Well, you're hearing history. This is the first time.
Welcome to Moving Forward, the radio ministry of Dr. Stephen Rummage.
This is the first
What happens when you're anxious?
NuTube Regen. Guess what? It's working. And the Regen pot's only at about 20%. How do you like that? As you can see, both tubes are happily fluorescing. They are in fact vacuum tubes. 60 volts on the plate. We have a negative voltage to bias the audio amplifier, which I have not got adjusted critically, but I have it adjusted so there is some Class A flow. And the Regen stage is self-biasing using good old-fashioned grid leak.
Yes, I've been so encouraged by this message, Promises That Never Break.
So it seems to have plenty of feedback at, above about 1,000 kilohertz, above 1 megahertz. But when you get below that, there's not enough feedback. So this is where we need to lift up the tickler. See how that works? That's just proving we don't quite have enough feedback at these lower frequencies.
At a school in Melrose in Gloucester today, the governor says most schools have a certain number of days they can miss each year, and that's why in person this school year. Baker also said anybody on-site vaccine setup.
Okay, let's measure the current going into the amplifier with the bias set.
The TV was on, and
We're going to turn down the volume, and let's see what we've got on our 10K resistor. Okay, 158 millivolts means 15.9 or 16 microamps. Remember, our budget is 20 microamps to actually over dissipate the audio amplifier. So we're on the load line, we're in a safe place, and let's see what the bias is at that point. Remember, the bias is set on the bottom of the potentiometer. Minus 0.7 volts. So with the 60 volts we do need a negative bias, but in order to get that 15 microamps we only need minus 0.7 volts. We don't even need minus 1 volt. That means I could probably get away with just having a single AAA cell rather than two of them and the potentiometer. Now ideally you'd like to just put the cell in series, so when the tube is not conducting, it naturally cuts itself off, and you can just leave the bias battery in there all the time. That's the way they used to do it in the old days. That way the bias battery wasn't constantly being discharged by that pod I have in the circuit that adjusts the voltage of the bias. So this is 610 kilohertz. I found by bringing the tickler coil up a little bit so that it's increasing the feedback into the main coil, using this old wire nut to lift it up a little bit, I'm able to get regeneration down toward the bottom of the AM band.
9/11. You have many families that lost loved ones on 9/11. I lost friends on 9/11. A lot.
Okay.
Wearing a black hooded sweatshirt with a Berkshire Nautilus logo. That's a health club in Pittsfield. He's described as a white male, about 6 foot tall, mid to late 50s, with white hair and brown eyes. Anybody with information is asked to contact the FBI. Organizers of a right-wing rally set to be held in Washington later this month are promising to be peaceful. Law enforcement, though, not convinced.
The number one request is to be a rally taking place September 18th that aims to support the insurrectionists charged in the January 6th riots. And with extremist groups like the Proud Boys and Oath Keepers planning to attend, law enforcement officials are planning for the worst. Brainerd's followers believe that more than 570 people who have been charged with federal crimes in the January 6th attack were nonviolent and reasonably believed they had permission to enter the Capitol. I'm Mike Bauer.
So I hope you got something out of this video, and maybe it is an experimental item, maybe it is a toy, or just a curiosity, but the KORG NuTube is foundationally just another vacuum tube.